A glass of milk and a slice of bread do not look like medicine. But a new study from UC Riverside suggests that specific proteins in these two everyday foods can make it dramatically harder for cholera bacteria to establish themselves in the gut. The magnitude of the effect surprised even the researchers who designed the study, and the mechanism they uncovered points to something much broader than cholera alone. The research found that diets high in casein, the main protein in milk and cheese, and diets high in wheat gluten sharply reduced how much cholera bacteria could colonize the intestines of mice. The difference was not marginal. The research team observed up to 100-fold differences in the amount of cholera colonization based on diet alone. The senior author of the study, an associate professor of microbiology and plant pathology at UC Riverside, said he was not surprised that diet could affect someone infected with the bacteria. What surprised him was the scale of the effect. To understand why this finding matters, it helps to understand what makes cholera so dangerous. Cholera is a severe bacterial infection caused by Vibrio cholera. It causes extreme diarrhea that can lead to rapid dehydration and death if untreated. Public health responses to cholera outbreaks focus primarily on clean water, sanitation, and rapid oral rehydration therapy to replace lost fluids and electrolytes. Antibiotics can shorten the duration of illness, but they do not neutralize the toxins that cholera bacteria produce. Those toxins continue to cause symptoms even after the bacteria themselves are cleared. The new findings from UC Riverside point to a different layer of defense, changing the conditions in the gut before a pathogen can establish itself. The study design started with a straightforward question. Scientists already know that diet strongly shapes the gut microbiome, the community of microbes living inside the intestines. The UC Riverside team wanted to know whether diet could also shape the fate of an invading pathogen. They fed mice carefully designed diets emphasizing different macronutrients: high fat, high simple carbohydrates, and high protein. Then they measured how effectively cholera bacteria colonized the gut after infection. The results were clear. High-fat diets did little to slow the infection. Diets rich in simple carbohydrates produced only limited protective effects. But diets high in dairy protein or wheat gluten virtually shut the pathogen out. Among high-protein sources, casein and wheat gluten were the two clear standouts. Now here's where the mechanism becomes genuinely interesting, because the protection is not simply about nutrition feeding the host. The researchers looked for a biological reason behind the dramatic reduction in colonization and found that casein and wheat gluten appear to suppress one of cholera's primary weapons for taking territory in the gut. Cholera bacteria carry a microscopic structure on their surface called the type 6 secretion system, or T6SS. Think of it as a tiny syringe-like weapon the bacteria use to inject toxins into nearby cells, including the competing microbes already living in the gut. When cholera can kill off these neighboring microbes, it clears space and resources for itself to multiply. In the study, when this system was suppressed by the dietary proteins, cholera struggled to take over. Without an effective type 6 secretion system, the bacteria had a much harder time killing other gut microbes and claiming the territory they need to grow. The resident microbiome, the community of bacteria already established in the gut, held its ground more effectively. The proteins did not simply nourish the host. They appeared to change the rules of the microbial competition happening inside the intestines. This is a meaningful reframe of how infection works. Infection is not only about the pathogen's virulence, it is also about the environment the pathogen enters. What you eat shapes that environment. A gut microbiome supported by the right dietary proteins may be better equipped to resist colonization by an incoming pathogen before treatment even begins. The public health implications of this finding are particularly relevant in regions where cholera remains a serious threat. Cholera continues to cause outbreaks in parts of Asia and sub-Saharan Africa, where clean water access is limited. Current treatment is effective, but has constraints. Antibiotics address the bacteria, but not the toxins they leave behind. And overuse of antibiotics carries the risk of contributing to drug resistance, a concern that applies to many pathogens, even if antibiotic-resistant cholera is not yet an immediate threat. Dietary strategies are appealing from a public health standpoint, precisely because they do not generate antibiotic resistance pressure the way drug-based treatments do. The senior author made a specific point about the regulatory advantage. Wheat gluten and casein are recognized as safe food ingredients in a way a new drug or microbe is not, which makes them an easier pathway for protecting public health if their protective effects are confirmed in humans. That caveat matters. The study was conducted in mice. The researchers are clear that human trials are the necessary next step before dietary recommendations can be made for high-risk populations. However, the senior author expressed confidence that high-protein diets would produce similar effects in humans and indicated plans to test the findings using human gut microbiome models. He also suggested that similar dietary effects might hold for other gut pathogens beyond cholera, which would significantly broaden the implications of the research. There are open questions the study does not yet answer. How much protein is needed to reduce infection risk meaningfully? Does the timing of dietary change matter more before exposure, during infection, or both? Do the same effects hold across different gut microbiomes, shaped by the dietary patterns of different regions and populations? These are the questions the next phase of research will need to address. What the study does establish is a clear mechanism worth pursuing. The type 6 secretion system that casein and wheat gluten appear to suppress is a specific identifiable target. Future research can test whether this suppression holds across different pathogens that use similar weapons in the gut, which could point toward dietary approaches for reducing the severity of a range of bacterial infections beyond cholera alone. The broader takeaway is one the senior author put simply: food does not only fuel the body, it also shapes the invisible community living inside the gut, and that community can influence whether a pathogen thrives or fails. The research is still at an early stage, but the scale of the effect observed in mice, up to 100-fold differences in colonization based on diet alone, makes this one of the more striking findings in gut infection research in recent years. And here's the piece that extends this finding beyond the specific context of cholera, because the mechanism the researchers identified has implications that go well beyond a single disease. The type 6 secretion system that casein and wheat gluten appear to suppress is not unique to cholera. Multiple gut pathogens use similar molecular weapons to compete inside the gut. The senior author specifically suggested that if similar experiments were conducted on other gut pathogens, dietary effects would likely be found there too. This opens a line of research that could fundamentally change how nutrition is understood in the context of infectious disease, not just as background support for immune function, but as an active modulator of the conditions that determine whether a pathogen can establish a foothold at all. For most people in low-risk settings, this finding is a scientific development to follow rather than an immediate behavioral directive. The research has not reached the point of producing dietary recommendations. But for researchers, public health officials, and anyone interested in the frontier of how food shapes health at the microbial level, this study represents a genuinely significant development. The gut is not just a passive recipient of what you eat. It is a dynamic battleground where diet sets the conditions for who wins. New videos every day covering the emerging science on how what you eat shapes your body's defenses and overall health.